we're going to talk about link aggregation, specifically layer 2 EtherChannel. Link aggregation is the generic term or the term used overall for bundling links together. EtherChannel is the term that Cisco uses on its devices or in its literature. So we want to bundle links. What is an EtherChannel? An EtherChannel allows you to bundle multiple physical links into one logical link. So we have our logical link, which is what we also refer to as our port channel. So when you hear things like EtherChannel and port channel and link aggregation, all doing the same thing, bundling links in some way. The port channel is the logical link. The physical links we often refer to as our members, so they're the member of the port channel. And when we go through and configure it, we'll go through and configure it, and I'll actually show you that a new interface is created, and it's the port channel interface. So why might we want to do this? Well, we can increase our available bandwidth. In spanning tree, it appears as one link, so we remove that loop issue and having one end of the link be blocking, and redundancy. So I can have, so when I EtherChannel, let's go through and let's just draw it over here. Okay, so I've got a switch. Whoops, don't want to do that. All right, I've got a switch here. Terrible switch. You have to bear with my drawings. And I've got some links connected to another switch. Switch 1. Switch 2. I can, let's say they're each 10 gig links. I've got a lot of bandwidth, a pretty awesome enterprise. Each of these links are 10 gig. I have a couple options. Well, let's say here, let's add one more. That way our math will work out nicely, right? I want to increase my bandwidth on this 10 gig, okay? I want more than 10 gigs across this section. I can do one of two things. I can combine these or bundle these or aggregate these, whichever term you want to use, right? And then I have 4 by 10. Or I can buy new 40 gig switches that have each interface running at 40 gig. So a little more cost effective. If I have the interfaces available, why not? And then also we look at the redundancy piece. We'll look at the spanning tree piece because we want to look at how it behaves. It's kind of cool. But the redundancy piece is this. If I have one 40 gig link and that link goes down, I now have no connection between switch 1 and switch 2. If I have 4 10 gig links and say this link goes down, these guys will stay in the bundle. So not only will I still have a link, I'll still have a link greater than 10 gigs. So I still have increased my bandwidth and my effective bandwidth, but not quite as much as the 40 I originally had, but I still have a link and I've still increased my bandwidth. So that's what we look at, an additional layer of redundancy between the two. We have a couple protocols that dynamically will help you dynamically negotiate each end of the EtherChannel, and that is Port Aggregation Protocol or Link Aggregation Control Protocol, or PAGP and LACP. With PAGP, I can aggregate up to 8 ports, or up to 8 ports can be in a bundle. With LACP, up to 16 ports can be bundled. Only 8 will be active, the other 8 will be in standby. EtherChannel uses a load balancing logic over the bundled links. It's kind of an interesting thing. And I'll save that for another discussion. But in general, it has a way of, I'm going to say, load sharing. It's not really a full balance, because it is possible that if I configure the wrong load balancing, that one link always gets used. Maybe this link gets used 90% of the time, and these other ones only get used 10% of the time. So it's more of a load sharing or a load distribution than it really is a balancing. But we continue to use the term because we can configure it so that it balances the traffic better, but we have to know more about the flows in our traffic. Okay. But it is possible, and something we have to be careful of, that I could actually not distribute over these links very well. So you have to understand your traffic pretty well, and I will save that for a later time. And I still use the term load balancing because that's the term you use to configure it also. So one thing to know about it when we do configure it, it's not something right now, but one thing to know about it when we do configure it, it is configured globally. That means it applies to all ether channels. So if I have another, let's say I have another switch up here. Wow, it's getting a little messy now. And I've got another ether channel here. And I configure source destination MAC as my load balancing. It's configured globally, so it will use it on this ether channel and on that ether channel. I can't do it individually for each ether channel. So when I am going to go ahead and bundle my links, and they've got to connect at each end, what needs to match? My interface speeds need to match, my interface duplexes need to match, the VLAN on the link, trunk links, the VLANs allowed. Okay, so what does that mean? Interface speed and duplex, right? Kind of self-explanatory. They need to match. The VLAN on the link means if I have my two switches, okay, and I'm bundling these 3 links, all of these links, if they're not trunking, have to be in the same VLAN. So if these are all in VLAN 10 on this side, they all have to be in VLAN 10 in order to bundle, plus we've got to pass to the same VLAN on the other side. If they're trunking, we have to have the same VLANs allowed. So remember, by default, when we configure trunk links, all VLANs are allowed. If we do some sort of manual pruning with the VLAN allowed command, we have to make sure they're the same on each side. So if I have 10 and 20 allowed over this link, then it also has to be allowed over this link and this one, and 10 and 20 here, and 10 and 20 there, and so on. Trunking protocols have to match. So if I have the option to do ISL or .1Q, if I'm doing .1Q on one side, I have to be doing .1Q on the other side, and I have to be doing .1Q amongst the 3 links that I'm going to bundle. Okay, some things to pay attention to. And again, I mentioned our dynamic ether channeling protocols, PAGP or LACP, in the previous slide. Then we also have the option to statically configure an ether channel, which means no protocol is used. PAGP is Cisco's protocol for ether channel. Okay. We have 2 modes, desirable and auto. Desirable desires, quote unquote, desires to form an ether channel. It will actively search out and try to negotiate with the other side to ether channel. Auto will kind of passively form an ether channel if the other side is actively seeking to form an ether channel. So I always say, if you're at a dance and the girls are on one side of the floor and the boys are on the other side of the floor, and they're both being passive, then there's no dancing that's going to happen. But if one or the other steps out in the middle of the dance floor and you've got one that's kind of auto, then he says, okay, well, you want to dance? Fine, I'll dance. That's good, no big deal. And that's kind of the difference. Desirable actually will step out in the center of that dance floor and say, I'm ready to dance. Auto will say, hey, you know what? If the only participants on the other side of the room, are just saying, okay, maybe, sort of, I don't really desire to, but if you want to, okay, then they will not form an ether channel because I have two passive folks, so to speak. So what combinations will form an ether channel? If I have desirable on one side link and desirable on the other side link, we will form an ether channel. So if I've configured the mode desirable on one side, the mode desirable on the other side, we're going to form an ether channel. If on one side of the link I have configured the mode as auto, and I've connected it to a switch that is configured in channel group mode desirable, they will form an ether channel. If I statically configure it, so this isn't using my PAGP protocol at all, and I set one side to on and the other side to mode on, that's how you can tell it's a static ether channel. It's on and on. They will form an ether channel. Any other combinations will not work. So if I can't mix static with dynamic, so I can't do desirable and on. I can't do auto and on. I can't do auto and auto. I can configure auto and auto, but we will not form an ether channel. So these are the only combinations that are going to form an ether channel. And if I look at link aggregation protocol, or LACP, my modes are active and passive. Active actively seeks to form an ether channel, same as the analogy before, right? It's actively looking to form a channel. Passive will passively form an ether channel if the other side is actively forming or desiring, actively seeking to form an ether channel. So if I'm configuring LACP, what combinations will form an ether channel? Okay. Swap out the words here. Active instead of desirable, right? So active and active will form an ether channel. Passive and active will form an ether channel. And again, static, which is on and on, will form an ether channel. And same thing here. We can't mix them. So I can't mix on with active. I can't mix on with passive. And I can't do passive and passive and expect to form an ether channel because it's just not going to happen. All right, so now let's go ahead and let's look at the configuration. Let's go ahead and configure it. This is the topology that we're going to use. And these are the commands we're going to use. So let's make sure I got my pen. The commands start exactly the same. The only difference is what mode do I put them in? And the mode is going to tell me whether or not I'm using PGP, LACP, or no protocol at all, which means I'm statically configuring them. So I start with channel group, the group number, the mode, and then with PGP it's either desirable or auto. With LACP, it's either active or passive. And with static, the mode is just on. So since we have 3 ways of configuring it, and we have 3 groups of interfaces, let's go ahead and do it each way so that you can see them every way. So we'll do PAGP here on these links, we'll use LACP on these links, and we'll statically assign on these links. Okay, so it's okay to mix our ether channel types throughout our network. It's just fine, as long as both ends of the links match, which means I can't do PAGP here and then do LACP here, or try to do on and then something else down here. That I can't do. But as long as both ends match, I can intermingle the way I do my ether channeling throughout my network. PAGP and LACP will dynamically negotiate the terms, will dynamically negotiate the ether channel and give us errors if something doesn't match. So if we have a speed or a duplex match or a VLAN match or a loud VLAN match or a trunking type, maybe using ISL at one end and .1Q at the other end, these guys are going to tell us. They're going to dynamically negotiate it. If they can't, they're going to say, hey, there's a misconfiguration, I can't. The issue, good, bad, or indifferent with static is that I set them to on and they believe they're on. I can configure this end as a static ether channel and not configure this end. This end will still believe that it's ether channeling. And we'll look at that and we'll see that. Not a bad thing. I'm kind of a fan of statically doing things just because I think that whenever you're negotiating something, you're using bandwidth you don't need to use and you add inherent security risks or issues. That being said, what you might want to do or an option is to use a dynamic protocol at each end. Well, first, know your network really well. If you know your network really well, fine. If you know everything is the same at each end the way it's supposed to be, then configure your static and you'll be fine. If you're not 100% sure, one of the things you could do is use a dynamic protocol at each end, maybe configure PAGP here. Once PAGP does the work of negotiating that ether channel, then maybe I could just want to change it to channel group mode on. You could do that. That's a possibility. One of the things we discussed is, so we bundle, we get bandwidth fine, but then we also discussed the issue of spanning tree seeing these 2 links as only one link. So now normally spanning tree would block one of these ends, right? Because this traffic could go from here, loop back around to here, and then keep looping back around. So this is a loop here. Each one of these sections are a loop. Spanning tree would inherently say, okay, well, I need to do what I do, and I'm going to have to block one of these to make sure there's no loop. Once I ether channel them, this won't be a loop. Now the issue is this whole thing will be a loop, right? Because I got my switches in triangles. So when I go ahead and, wow, that was like way out there. That was a terrible straight line. When I go ahead and I combine these into an ether channel, that's great and that's fine. I don't have these smaller, I don't have 4 loops in total, because if you think about it, prior to ether channeling, I have 1, 2, 3, 4 loops, 3 loops, plus then our bigger loop is 4. Mine's being one of those little box puzzles. How many squares do you see? When I combine them, I just have one big loop, and ether channel and spanning tree will still have to process that, but it won't block each one of these links on here. So let's get rid of our mess of something here, and then let's go and rewrite that, hey, you know what we're going to do? Whoops, not there yet. We are going to do PGP here, we're going to do LACP here, we're going to do static. And before we do that, we want to go ahead and look at spanning tree. So I'm going to bring up my terminal windows, and we're going to go ahead and look at spanning tree. We're going to look at spanning tree before and after we configure everything. All right, so I pulled up my window, and I've left everything at default. And default means there's no trunks. Everything's in VLAN 1. So if we do a show spanning tree, and we hit enter, everything's in VLAN 1. What we see here is on switch 1. Switch 1 is our root switch. A couple ways we know is it says this bridge is the root. One key here is when we started looking at our interfaces, they were all forwarding. Okay. Whoops. So that's what our spanning tree looks like there. Now let's go into switch 2 and do show spanning tree. Here we've got one interface blocking, which was gig 2. So he's blocking. I'll go back and put this on the topology, don't worry. He's the only one blocking. Now if we go into 3 and we do a show spanning tree, all kinds of blocking ones here. We've got gig 1, gig 2, and 1, 0 blocking. 1, 0, and 1 and 2. So let's see how and if we broke our loops. So what did we say? We said on switch 1, everything is forwarding. Forwarding, forwarding, forwarding. And what was switch 2 again? Now I don't remember. I have to go back and look. Well, we got to go back. Here, we look back. We had 1 and 2 blocking and 1, 0 blocking. So nothing can forward here because both of these ends are blocking. But if this guy needs to send something, he can send it here, and then it'll go there. But the loop is broken here because this guy is forwarding, but he's forwarding towards something that's blocking. So we've broken the loop. Our spanning tree's broken the loop. Now let's go ahead and configure our ether channels and see how spanning tree behaves. All right. Int range GI 0/1 to 2. Our channel group command, right? Channel group. We'll make this group number. Wow. We'll make this group number 1. Mode desirable. I'll make both sides desirable. That will form a trunk. And then notice my new interface, my virtual interface, my port channel is created. Something interesting to see, if I do a show ether channel summary, okay, I've only configured one side, so what happens here is it shows us down. Let's look at so we have port channel is SD. What does that mean? It means it is layer 2, and it means it's down. It's not running. Also, next to each of our member interfaces, we have I, which means standalone. We're not bundled yet. And clearly we shouldn't be. We haven't configured the other side, right? Let's finish up with this though, and let's go ahead and do our static ether channel since we're on switch 1. So we do int range GI 0/3 space comma 1/0, whoops, 1/0. Oh, gig, sorry. Gotta tell it the interface type. There we go. Channel group. Let's make this channel group 3, mode on. What's interesting here is if I do a show ether channel summary, should I type the whole thing out? Let me type it all out. Ether channel summary. Notice the difference. My dynamic protocol talks to the other side and realizes, hey, you aren't configured yet. We have some inconsistencies. When I configure static, it actually believes that it's up. It's SU and P. So what is that? It means layer 2 still. Where'd layer 2 go? There we go. It means in use, which tells me it's up. And P tells me they're bundled. So that was what I was talking about before when I said if you do static, even though the other side is clearly not configured to bundle or to be an ether channel, it believes that it's running and everything's just fine because it's not dynamically negotiating it. It's not checking to see if the other side is configured correctly. So let's go into switch 2. And let's finish the other side of this PAGP ether channel and start our LACP channel. All right, so config T. Int range 0/1 to 2. Gotta give it the type. Gig for GI for gig. Channel dash group 1 mode desirable. Let's move this out of the way. And we'll give it a second. We're going to go check our ether channel. We see it's up. We can also see that our port channel interface came up. So that pretty much tells us our ether channel is running. So if we do a show, and I remember you don't have to complete the command as long as it's enough for the iOS to understand it. So do a show ether channel summary. Apparently that was not enough for it to understand it. I think it's got to have a C, otherwise it's Ethernet. And now our port channel is up. If we went to the other side, it would show up as up as well. So now let's start the configuration of our LACP ether channel here. So we go int range our gig 0/3 space comma space GI 1/0. And what is the difference here again? Channel group, a group number, we already used 1 and 3, so we're going to use 2. Remember the mode is different. So if we do mode space question mark, we want to use active or passive for LACP. We're going to use active. Creates the interface. Show ether channel summary. Okay, creates the interface, but it's down. That's what the D means. So if we go back up here, down. Makes sense again, right? Because we didn't finish. So let's go down to switch 3. Have we done anything on switch 3? I don't think so. So we do config T. Now let's do the other end of our LACP link, and then we'll do the other end of our static link. Int range GI 0/1 to 2. I can move my mouse out of the way. Channel dash group mode active for LACP. And give it a second. And our port channel interface came up. So we should be doing pretty good at this point. Let's go ahead and do int range GI 0/3. Comma 1/0. Oh, I just forget the second one when I have to do ones that aren't contiguous to make sure I get the interface type in there. Gig 1/0. Channel dash group 3 mode on. Okay. Now if we do a show spell. Trying to tab complete. If you can't tab complete, probably spelled it wrong. So do a show ether channel summary. And now all of our ether channels are up. Now we could also do a show ether channel if you wanted. Show our 2 different groups. Show our protocols. No protocol. Now let's do a show spanning tree. Now if we note in spanning tree, switch 3, instead of having 4 interfaces, it has 2, both of our port channels. Let me go back to this for a minute. And I'm going to erase all of our ink. And what I want you to see is now, this is one link right here, right? Try to make this, fill this in. I'm going to color this in. This is one link. These two together are one port channel. What is this? This is port channel 3. Wow, that was a terrible 3. This is port channel 2. This is port channel 1. They're not seen anymore as separate links. They're seen as one larger bandwidth link. So now if we go back and look at our spanning tree, so we bring our terminal back up, and now we've got port channel 2 and port channel 3, 2 and 3. Now notice exactly what I said was going to happen before did happen. We still have our large, we've got rid of these, these loops here, but we still have this loop here. And so now we have port channel 2 is blocking, and port channel 3 is forwarding. So 2 is blocking, 3 is forwarding. Let's go into switch 1 and do a show spanning tree. And everything is forwarding. So port channel 1 and port channel 3 are forwarding there. And if we do a show spanning tree here, they're both forwarding. Right? Which is actually fine, because we still broke our loop. It did what it was supposed to do. So if we go back and label them, this guy is forwarding, this guy is forwarding, this guy is blocking, right? And then this guy is forwarding and forwarding. So we've broken our loop here. This link's not going to be used. So things for switch 3 will be forwarded to switch 2 this way. Switch 2 will send stuff this way. There's never going to be a loop now. So that is actually the end of our EtherChannel discussion. Later we'll look at load balancing or load sharing across ether channels. But that's the end of configuring ether channels and the theory behind ether channels.